Hey guys, it's Mr. Wishart, 8th grade math teacher, doing some 7th grade math with you. All right, guys, this is topic 5.1. It's the first section. First section in chapter 5, topic 5, right? This is about writing two-step equations. So we're just going to start with this one right here. We've got these two dogs right here. We got Marley, this West Highland Terrier, and we got Tucker, this pug, right? They both collect golf balls. Marley collects golf balls. His neighbor Tucker collects 3 more than twice as many golf balls as Marley. So obviously this dude's better at his job, right? Okay, so what we're going to do is we're going to use a table to represent the number of golf balls in Marley's collection M and the number of golf balls, or I should say T, in Tucker's collection. Okay, you want to say hello?
Hi.
That's my son Deacon. My dog is also bugging me right here. Let's see if we can get a good picture of her. Anyway, give me some space.
I want to learn math though.
Well, can you sit over there? I don't know. Go. Okay, so we're going to use a table to represent the number of golf balls in Marley's collection M and the number of golf balls in Tucker's collection, which is going to be T. So I'm just going to set up kind of a sideways T chart right here. And I'm just going to start out with, I don't know, making some cells in this table here. Dirt. Okay. And so let's see if I have, let's see if Marley, remember that's the dude on the left. He's not quite as good as his job as Tucker, but he's still pretty cute. If he collects 1 golf ball, right? The relationship here where Tucker collecting 3 more than twice as many golf balls as Marley, we can use that to generate the number of golf balls that Tucker collects, right? So if we take this 1, we know that it's going to be twice that. So 2 times 1 is, sure, go get some orange juice. So we take that number of golf balls that Marley collects and we multiply it by 2. So 1 times 2 is 2. And then we add 3 onto that. So it's 1 times 2 is 2, plus 3 is 5. So we get to how many Tucker collects right there. Now, if Marley manages to get 2 golf balls, we do the same thing, right? 2 times 2 is 4, plus 3 is 7. Okay. Now, if Marley gets 3 golf balls, 3 times 2 is 6, plus 3 is 9. Some of you are probably noticing a pattern here, right? If I get 4 times 2 is 8, plus 3 is 11. And then we can keep going, right? 5 is going to get us 13, and 6 is going to get us 15, right? So you can start noticing that pattern of Marley's golf balls as they go up by 1. Tucker's golf balls go up by 3, but they start at go up by 2, but they start at a different number, okay? So how can you use an algebraic expression to represent the number of golf balls in Tucker's collection, right? So, no, I don't want you in the video. And so we know that Tucker, right, is going to get twice as many golf balls as Marley, and then add 3 onto that total, right? So twice Marley, we can represent that with 2 M's, okay, and then 3 more, right? We add those 2 M's together, and then we add 3 right there, right? We can simplify that a little bit by adding those 2 M's together, right? As a reminder, there's an invisible 1 in front of each of those M's, so it becomes 2M plus 3. So those are 2 different algebraic expressions that you could use to represent this situation, okay? All right, moving on. So we got example 1 right here. Write a 2-step equation to represent a situation. And we're actually continuing on the saga, the story of Tucker and Marley, the golf collecting dog balls. Gosh, I said that wrong. Dog. Let's see.
Treasure hunting
dogs who are looking for golf balls.
Yes.
Wow, I really messed that one up. All right. What expression can be used to represent the number of golf balls in Marley's and Tucker's collection? Well, we got a number on this one, right? We got 159, right? And we also have, again, that relationship of Tucker getting 3 more than twice Marley's golf ball collection. Okay. So if we kind of look at this little thing right here, Tucker's collection is represented in the dark blue at 159. It'll be kind of hard to read here, right? And we kind of, that expression that we used previously, where we have that, where is it? Sorry. That M plus M plus 3, we can actually just pop that into the light blue part of it. M, M, and 3, okay? And so the top part, that dark blue part, is going to be equal to the sum of the bottom part, okay? So we've got Tucker's collection right here, okay, is equal to twice Marley, and then some more golf balls. Okay, let me move that up a little bit. Tucker's collection is 159. Okay, because we know that it says it right there. It says it in the picture right there. Okay, and we'll just use the equal sign, right? So 159 is equal to twice Marley. So we've got these two M's right here, which we can combine to 2M, and then more golf balls is that 3 right there. So plus 3. So we've got our equation here. An equation is different than an expression because an expression has an equal sign, right? So let's compare the difference here, right? I've got this 2M plus 3. This is an algebraic expression. And this is an equation. When you add that equal sign, it becomes an equation, okay? All right, this kid Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments. P, what equation represents the relationship between the cost of the laptop and Cole's payments? Shoot, I should have made this bigger when I made it. But anyway, the cost of the laptop, we know that's $335. Boom, we put that right there. We know that the down payment is $50, so we can pop that right there. And then we've got 1, 2, 3, 4, 5, 6 monthly payments represented by those P's, right? And so what we can do is we can kind of just add these up, and there's 6 of them, right? So we can say, 6P, and then we add the month or the down payment onto it. And then we set it equal to the cost of the laptop, $335. Now, we're not solving any of these in this part of the chapter. We're just writing the equation. So just be aware of that, okay? All right, let's just more examples of this, right? So we've got a baseball that weighs 25.75 ounces less than a bat, right? Less, that means minus, okay? Write an equation that represents the relationship between the weights of a baseball and bat in terms of the weight of the box W. So we have this box right here, which contains 50 bats and weighs W ounces, and we have the baseball weight 5.25 ounces. Boom. Okay. So the weight of one baseball, and we get that number right there, that 5.25. Okay. The weight of one bat. We're not given the weight of one bat, right? However, we know that this box has 50 of them and weighs W ounces, right? And that's the weight of the box, that W, right? So the weight of one bat is actually the total of that box, which is that W, you divide by the number of bats in it, right? Okay, so that's W divided by 50. And then you subtract the difference in weight, which in this case is that 25.75 from the problem right there. Shift that up like so. So that's how we would write that equation. The weight of one baseball is equal to basically one bat minus 25.75. This W over 50 represents the weight of one bat, which clearly says that right there. Okay. All right. Okay. Interpret quantities and operations and equations. So this girl Claire bought 8 tickets for a total cost of $104. She'd used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation? We've got 3 different variations. They're all equal to 104, right? So that doesn't help us distinguish anything, but they are set up with some parentheses and just different operations happening, right? So if we take a look at this first one, what we get is there's this $3 discount, because we know that's the $3 discount. That's the coupon code. Okay. We have a $3 discount times the cost per ticket. That's the X value times the cost per ticket minus the number of tickets, right? Which doesn't describe the situation at all, right? We're not taking that discount and multiplying it by the cost of the ticket minus the number of tickets. So that doesn't make sense, right? Take a look at this one. Let's do a different color here. We've got 8 tickets times 8 tickets times the cost of the ticket minus like a $3 discount off the top of it, right? So we've got 8 times, which is the number of tickets, right? So 8 times the cost of a ticket minus, that's ticket, minus the $3 discount, right? But we know that the discount applies to each ticket. It's not just $3 off the top, right? So that doesn't work right there, okay? So now we've got this last one right here where we have 8 tickets, boom, on the outside, perfect. 8 tickets, and then times the cost of the ticket. Minus the discount for each ticket, minus the $3 discount on each ticket, right? Because it's being taken away from each ticket, okay, on each ticket. So, and that actually describes the situation very well, which, you know, that's what it matches up to. So that's kind of the one we would select there. Okay, awkward.
Hang out, guys.
All right, guys, that's gonna do it. I hope you enjoyed. That there are 3 of these problems that you'll see on CMAS. They're not part of this chapter, but I would like you to try these. Let's actually do the first one together, and then I would like you guys to work on the rest by yourself. So the idea is that you're gonna evaluate the expressions for each given value of the variable, right? So since x is equal to 0, what I can do is I can take that 0 and I can plug it in here. So it becomes 3 times 0 plus 2. The x completely goes away and is replaced by that number, right? So 3 times 0 is 0, plus 2 is 2. So that's kind of how you'd solve it, right? You'd take that 8 and plug it in for the b. You take that 20 and plug it in for the t. Sorry, I went out of focus there. Yeah, anyway, there you go, guys.
Yeah.